Question 2a. Find an antiderivative of 1 on 3x minus 4 with respect to x. And I've set up the antiderivative here, and this 3x minus 4 on the bottom is really 3x minus 4 in brackets to the power 1. When that power is a 1, the antiderivative of 1 on that linear function always becomes a log function. So the antiderivative of this is just the log to the base e of the absolute value of that linear function. And then the key thing you've got to do is divide the whole thing by the derivative of that linear function, which is 3 in this case. And then plus c, or you can leave the c out because they've said an antiderivative. So either of those two would be acceptable. And you can always write this in this form, 1/3 log e of the same thing, and either with the c or without it. Now, I wanted to mention this because a lot of students get a bit mixed up with these kind of antiderivatives. So when you have 1 over a linear function to some other power other than 1, you antiderive them differently. So there's really only two cases, when the power is 1 in this case, and when the power is not 1. So when it's not 1, you antiderive this in the same way that you would antiderive 1 on x squared. Express the x to a negative power, set up the antiderivative, and then you increase the power by 1 by adding 1 to minus 2, and then divide by that new power. And then you would end up with x to the minus 1 over minus 1, which would become minus x to the minus 1. And you do this in the same way. So set it up as 3x minus 4 to the minus 2, antiderive it by adding 1 to the power, dividing by that new power, so minus 2 plus 1 is minus 1. You also have to divide by the derivative of what's in the bracket here, which is 3, and then this becomes minus 1/3, 3x minus 4 in brackets to the minus 1 plus a constant, or leave out the constant. So two different ways of antideriving this kind of question depending on what the power is on the linear function. Part B, solve the equation 4 to the x minus 15 times 2 to the x equals 16 for x. So in other words, what does x equal that will make this equation true? And the first step I've done is to put the 16 on the same side, so minus 16. And then the key with this kind of question is this bit here. So this is 15 times 2 to the x. Somehow you've got to make this into 2 to the x to some power, and then the whole thing will become a quadratic function, or a quadratic equation of that whole equation, if you like. So I've shown the steps of that here. 4 to the x is really 2 squared to the power x, and then getting rid of this bracket, you multiply these powers, so that becomes 2 to the 2 times x. That can be written as 2 to the x times 2, and then that can be written as 2 to the x to the power 2. So the rule, when you've got a power to a power, you always multiply those powers. And so I've got it in the form I want it in, and as I've done in this step here. Then I'm going to let w equal to x, and then replace this 2x with a w, so that becomes w squared. This becomes minus 15 times w, and then the minus 16 equals 0. And now it's a more easily recognizable quadratic equation. And that's the whole point of letting w, or a single letter, equal this part here. So that can be factorized to w minus 16, w plus 1. And from there, w does equal 16 or minus 1. And then in the next step, replacing these w's with 2 to the power x, as I've done up here. So 2 to the x equals 16, or 2 to the x equals minus 1. Now, first of all, this one, 16 is equal to 2 to the power 4, and because the bases are the same, that means the powers are also the same. In other words, x equals 4. Now, with 2 to the x equal to minus 1, there's no number that you can raise 2 to the power of that will give you minus 1 for an answer. And you can confirm this by looking at the graph of y equals 2 to the x, and this graph will approach the x-axis as x becomes more and more negative, but it will never cross it. So there are no negative y values on this graph, which really means that there are no x values that you can put in here into 2 to the x, substitute it in there, that will give you a negative y value. So what that means is that there are no answers to this part of the solution. So the answer to the question is x equals 4.